Dear students, in today's session, we are going to see types of chemical reactions. In the previous class, we have discussed what is a chemical reaction, chemical equation, how it can be represented, and how it can be balanced. Am I right? Well, there are 5 types of chemical reactions. One is combination reaction, second one is decomposition, third one is displacement, fourth one is double displacement, and fifth one is redox reaction. Let us see these reactions in detail in coming classes. Today we are going to see 2 types of chemical reactions. The first one is combination reaction. What is a combination reaction? A reaction in which 2 or more reactants combine to form a single product is called combination reaction. Hope you understood. How many reactants? Yeah, more than 2, and the product should be a single one. Many examples are there. Carbon reacting with oxygen gives carbon monoxide or carbon dioxide. Carbon one reactant, oxygen one reactant, carbon monoxide or carbon dioxide. Anyone? It is a product. And another example, hydrogen reacting with oxygen to form water. Here hydrogen, oxygen, 2 reactants, water is a product. Now let us see one example with an activity. I have taken in a test tube quicklime. What is quicklime? It is none other than the powder which we are using for whitewash. Quicklime, its formula is CaO. Chemical name is calcium oxide. Hope you understood. Quicklime, formula is CaO, calcium oxide. I am going to add some water to this. Here, water reacts vigorously with the quicklime and form a milky substance called slacked lime. And now when I touch the wall of the test tube, it is hot. These are 2 observations. A milky substance called slacked lime is formed with the evolution of some heat. Here, 2 reactants. One is quicklime CaO and I added water H2O is another reactant. It forms a single product slacked lime. Okay, what is its formula slacked lime? CaOH twice. CaOH twice. That means calcium hydroxide. Hope you understood it. Is it? One example already we have seen, that is calcium oxide is reacting with water to form calcium hydroxide, CaOH twice. Okay, here we have to check whether the equation is balanced or not. Calcium 1, this side calcium 1. Okay, it is balanced. Here hydrogen 2, this side hydrogen 2. Am I right? This 2 is common for O as well as H. Okay, balanced. And look at oxygen. Here 1 oxygen and here 1 oxygen. And here 2. So the equation is balanced one. Another example let me write, that is hydrogen reacting with oxygen to give water. It is also an example of combination reaction. So we have to balance. Is it hydrogen this side 2 balance. But oxygen here 2, that side 1. This side is less. So I have to put 2 in front of this one. Now oxygen is 2 but hydrogen is 4. So this side only 2. So how will you make 2 into 4? Yes, if you are putting 2 here means hydrogen is 2. And another example, carbon is reacting with oxygen, gives carbon dioxide. Here also 2 reactants and single product. And one more reaction let us see now, that is exothermic reaction. What is an exothermic reaction means? A reaction in which after the reaction heat is evolved, means that is exothermic reaction. Okay. Here CH4 is none other than methane gas, that is LPG gas. What do we use for cooking? While burning it is reacting with oxygen and gives carbon dioxide, water and heat. That heat energy only we are using for cooking, and these two are escaping into the atmosphere since they exist in gaseous form. Okay. Now another example for exothermic reaction is our respiration. While respiration, oxygen gas, it is reacting with the food what we take. The food what we take contains glucose. Its formula is C6H12O6. Then after reaction, it gives out carbon dioxide, water and energy, also heat energy. Okay, here you look into some amount of heat energy is escaped. That energy we use for our body's functioning and other thing, and these two are escaped from our body as waste. Okay, here we have to balance. Here C is 6, here C is 1. Is it? So I am putting 6 here. Okay, now carbon balanced. Hydrogen, you look here 12. This side only 2. Is it? How will you make 2 as 12? You can put 6 here. If I am putting 6 here, hydrogen is 12 and here also hydrogen is 12. Now oxygen you look into, here 6 and plus 2, 8. Here how much are there? 6 into 2, 12, and also here that 6 also 18. So how can we make it as? So if I am putting 6 here, now you look here, 6 into 2, 12, 12 plus 6, 18. And this side 6 into 2, 12, here 6 oxygen, so 18 oxygen. Hope you understood the reaction combination. The another type is decomposition reaction. It is just opposite of combination reaction. Okay, what is its definition? Yeah, it's correct. Yes, a single reactant decomposes to give 2 or more products. Reactant is 1, products more. But in the case of combination, reactants more than 2, product is 1. Okay, hope you understood the definition of decomposition reactions. There are many examples we can see. The first one, let me do an activity. I have taken some amount of iron oxide. Look at the color, light green color. Are you able to see? The color of This substance is green. What it is? It is iron sulfate. It is iron sulfate. Now I am going to heat it. Iron sulfate. FeSO4. Another name it is iron sulfate or ferrous sulfate. FeSO4. Color is green. Now I am heating the salt. I am heating. Then I can smell some gases, that is pungent smell, irritating smell. That means while heating, some gases are escaped. Here, some gases are escaping. Since it is very irritating nature, I cannot smell it also. But even though I am able to smell, it is very irritating and pungent smell. Now slowly I can see the green color substances changed into brown first. Are you able to see? Then now the gases are escaped. Now the substance left behind in the test tube is brown color. That is iron oxide. Okay, what we have taken, that is ferrous sulfate, green color substance. After heating, first the color is changed into somewhat white because some water molecules are present in iron sulfate, that is escaped first. Then when I heated continuously, it changed into somewhat grey or black color substance, that is iron oxide. After evolution of two gases, that is sulfur dioxide and sulfur trioxide, SO2 and SO3. Okay, we took only one reactant, that is ferrous sulfate, FeSO4. After heating, we got two gases, SO2, another one is SO3. Now the substance which one is left behind in the test tube is iron oxide, that is Fe2O3. Okay, so here from a single reactant, three products are formed. Now let us see the equation of the decomposition reaction. Here ferrous sulfate, FeSO4, it is in solid form, green color. When it is heated, so the condition you have to write heat, H-E-A-T. Heated, it gives brown color or somewhat black color substance, that is Fe2O3 in solid form, and two gases named SO2 and SO3 are evolved. They are very irritating and pungent smelling gases. Okay, this is one example for decomposition reaction. Second example, let us see CaCO3. This is calcium carbonate. CaCO3 is calcium carbonate. It is heated, so it forms CaO plus carbon dioxide. Okay, so CaCO3 is, another name for it is limestone, white color substance. When it is heated, it changes into CaO plus. What is CaO? Yeah, it's correct. That is quicklime. CaO is quicklime. Calcium oxide. Now check whether it is balanced or not. Ca. Oxygen 3, oxygen 1 plus 2, 3. 1 carbon, 1 carbon. In this equation, please check. Iron 1, but here iron 2. So you have to put 2 here. Iron balanced. What about sulfur? This 2 is common for this. So 2 yes, and here also 2 yes. Here 1 yes, and here 1 yes. Oxygen 2 into 4, 8. This side add 3. Since plus is there means you have to add, don't multiply it. And here 2, 5, and here 3, 8. The equation is balanced.